Okay, so let's solve this differential equation. So if I were to try to solve this differential equation, wouldn't that give me y dy equals x dx? So we get y squared over 2 equals x squared over 2 plus c. So when you rearrange that equation, doesn't that equation turn into y squared over 2 subtract x squared over 2 equals c? Do you remember that that is that general form of a hyperbola? You had x squareds and y squareds, but they were subtractions instead of additions. Remember, if it changes around and it's x squared minus y squared, then that's the one that opens up left and right. But if y squared comes first, it's opening up and down. Won't your value of c, if c turned out to be a negative number, wouldn't that switch this around? So the value of c is going to affect whether this hyperbola is a sideways hyperbola or an up and down hyperbola. So can you actually see the hyperbolic image in here before you knew it was going to be a hyperbola? Yeah. Okay. And if you plugged in these points and actually solved, you would get the particular equation of this function that you just drew. Okay. Let's look at the next one. Would you please sketch in the graph that goes through 0, 2? So please sketch in the function that you think goes through 0, 2. Look like that? Ish? Did you get that kind of a shape? All right. Let's graph the one that goes through 1, 0. Graph that image that goes through 1, 0. I'm still getting the same basic shape, aren't I? What does that shape look like to you? This is a hyperbola. Is this curving and coming back up? No, this is leveling out.
It's like the 1 over x.
Exponential.
Exponential, yeah. Yeah, this is definitely exponential growth. Yeah. Yeah, this is just an exponential growth curve. Well, solve this differential equation. Wouldn't dy equal e to the x dx? If you integrate both sides, don't you just get that y is e to the x plus some constant? Yeah. So that constant is determining which one of these curves it really is. But every time it's the same curve, right? E to the x. This is just a family of curves. Okay. All right, so when you look at your next one, anybody think you might know what's happening along here?
It's horizontal.
That's going to be a horizontal asymptote. If you look at that graph, hopefully you can kind of see that ghost image in there. If we're above it, wouldn't our shapes be coming down like this? But if we were actually below it, our shape would be coming up. But isn't there another one also? There's another horizontal asymptote in there. So these functions would be coming up to it. Down here, they'd be leveling off like that. Can you see those images in there?
Yes.
Okay, all right. So what do slope fields show you? You can stop it.
The slope.